Hello and welcome to release question number 2 for the Algebra 1 CST questions. Again, go back to video number 1 in this playlist and see what I had talked about there for a little more in-depth explanation of what we're doing here. But great review not only for the CST with these videos, but also for any Algebra 1 final exam or comprehensive test, cumulative test, or even just an overview of Algebra 1 if you're wondering what you're getting into by getting into an Algebra 1 class. But let's check out question number 2 now. So it says, which statement is false? Which one is not true, in other words? So choice A, the order in which two whole numbers are subtracted does not make a difference. So we've got whole numbers subtracted. Here we've got two whole numbers added, does not affect the sum. That just means adding them together. And then we're talking about something called rational numbers here and adding them together, and rational numbers and multiplying them together. So whole numbers, just for a recap of what that is if we don't remember what whole numbers are. Whole numbers, we're talking non-negative numbers. We can use 0, but we're also saying 1, 2, any positive number that's quote-unquote whole, just meaning no decimals, no fractions, things like that, things of that nature. So that list continues here. And rational numbers, that's a lot more inclusive. There's a lot more numbers that are rational. This is more like any number, or it is any number that can be written as a fraction. Or non-terminating, I shouldn't say that, I'm sorry. I should say terminating or repeating. I didn't mean non-terminating. So terminating just means it has an end to it, or terminating / repeating decimal. So I'll give you some examples of numbers like that. So for example, we could have, like 1 over 4. That'd be a fraction. You could have negative numbers. You could have negative 5 over 7. You could get pretty crazy. You could have 100,263 over 7,855. That would be a rational number. You could have these terminating and repeating decimals. You could have 9.632. That's a terminating decimal. It stops. It has an end. You could have things that repeat as well. You could have something like 10.84, and you could put that over that, and that just keeps repeating. So these are some examples, though, of rational numbers. Whole numbers, rational numbers, which one's true? I'm going to start from D and work my way up to A. Sometimes I do that. Sometimes I'm just thinking, they're going to make D the wrong choice, so I'm going to check that one first. So let's just see if my intuition works out here, or my theory works out. I'm going to start from the bottom, work my way up, and see if I can find the incorrect choice more quickly that way. So the order in which two rational numbers are multiplied does not affect the product. And so if I go back to video number 1, I'm going to refer back to that one here. We talked about the associative, commutative, and distributive properties of addition and multiplication. And so with this one, it says the order in which they're multiplied, rational numbers doesn't make a difference. So that's like this one right here. You can switch the order in which two things are multiplied, and it says that's going to hold. And so it doesn't matter what two numbers you pick here. I'm going to do some examples off to the side here of each one of these properties. So this, just because I'm saying or showing that one example works doesn't prove or disprove it, or doesn't prove it is true necessarily. But if I can show one counter example, actually, I have disproved it. And so I would show that it is false if I can show a counter example. So here's some examples or counter examples I think would be a good thing to add to that right here. So some examples or counter examples for these questions. If I took two rational numbers, let's keep it pretty simple here. 1/4 times 1/3, that would be 1/12. And does that equal 1/3 times 1/4? If I switch the order, the commutative property says I can do that, and then that in fact works out. That checks. Those two things are equal. The order in which two rational numbers are added does not affect the sum. So this was true. I can cross that off. But if I add two things together, let's keep it relatively simple here. So adding 5/12, I have to have common denominators when I'm adding things together. So let's go with 7/12. That would equal 12 over 12, which would equal 1. But does that equal these two added together in the other way? Well, yes, that's the commutative property of addition instead of multiplication. It says I can switch the order with any real numbers. A real number is even more inclusive than rational. All rational numbers are real numbers. These are properties back here that work for any real numbers, A, B, and C. And so choice C, not the correct choice there. That is true. So it was D. Choice B, the order in which two whole numbers are added does not affect the sum. So I could take 4 plus 6, that equals 10. I can switch the order, 6 plus 4. These are just examples again. It's not proving that this is true all the time, but it's at least showing an example of it being the case. So I'm thinking not B. So it looks like my theory didn't work out so well here. I should have checked A first. But hey, I went through them all. That's always a good idea anyways, especially if you have enough time to check all the answers, to go through everyone and make sure that even if you thought a certain one was right, that the other ones are actually the wrong answers. Good test-taking strategies there. So the order in which two whole numbers are subtracted here. So if I took, for instance, 4 minus 3, we'll keep it real simple, that's 1. But if I switch the order and take 3 minus 4, that equals -1. And so this and this, these are different numbers. And so is this one false? Yes, it is false. It's not true. We didn't get the same thing there and there. So number 2 is choice A.